What if the oldest truth in the universe can only be seen as it dies? The first galaxies didn't vanish. Time stretched their light into infrared, hiding it in plain sight. So we built a telescope that must stay colder than space, shielded like a secret, stationed far beyond Earth's noise, just to catch a fading whisper from creation. And the moment it opened its segmented mirror, the universe answered with surprises and new questions. Humanity has always stared upward, asking where we came from, how the first stars ignited, and whether we are alone, knowing answers hide not nearby, but deep inside ancient light. Hubble showed breathtaking galaxies, yet it mostly saw visible light, missing stretched infrared signals from the earliest universe, whose expansion quietly reddened ancient photons beyond ordinary vision and human instruments. Light from primordial galaxies travels billions of years, stretching with cosmic expansion, shifting into infrared wavelengths, meaning seeing the beginning requires eyes tuned to heat, not brightness and extreme patience. Infrared vision demands cold instruments, because warmth creates its own glow, drowning faint cosmic signals, so the telescope itself must become colder than space to truly listen to creation's whispers. To survive heat and noise, the telescope was placed near Lagrange point 2, far beyond Earth, where sun and planet align, allowing permanent shade and uninterrupted observation of ancient space. Capturing faint light requires a massive mirror, so engineers built a segmented, gold-coated eye, folded for launch, then slowly unfolded in space like a mechanical flower opening against infinite darkness. Every deployment step carried risk, because no astronaut could repair failures, turning unfolding mirrors and sunshields into moments when humanity collectively held its breath, waiting for silent confirmation from space. Once operational, Webb became more than a camera, using spectroscopy to split light, revealing chemical fingerprints, temperatures, motions, and atmospheres hidden within distant stars, clouds, and planets across cosmic history. When Webb looked deeper than ever, it found early galaxies surprisingly bright and mature, challenging models, suggesting the young universe formed structures faster, wilder, and stranger than predicted by theory. Some galaxies appeared elongated, clumpy, and chaotic, unlike neat spirals today, hinting early cosmic environments were turbulent, rapidly assembling stars under extreme conditions that defy simple evolutionary expectations models today. Webb's infrared vision penetrates cosmic dust, revealing stellar nurseries where gravity compresses gas, igniting newborn stars, and exposing protoplanetary disks that quietly shape future planets beyond visible light's reach alone. Inside these dusty cradles, heat, pressure, and rotation sculpt disks, collisions grow grains, and chemistry evolves, showing how ordinary matter organizes itself into complex systems capable of hosting worlds eventually. Webb also studies dying stars, where violent outflows and explosions forge heavy elements, spreading carbon, oxygen, and iron across space, seeding future generations of stars, planets, and life everywhere onward. These recycled elements eventually become parts of bodies, oceans, and air, meaning every atom in us was once processed inside stars, linking human existence directly to cosmic evolution itself forever. Turning outward, Webb examines exoplanets, analyzing starlight filtered through alien atmospheres, searching for water vapor, carbon dioxide, or methane, subtle clues hinting at possible habitability beyond distant suns, elsewhere someday perhaps. Reading atmospheres is difficult because stars interfere, masking signals, yet Webb sets limits, narrowing possibilities, teaching scientists how to separate planetary fingerprints from stellar noise with patience and precision discipline. Beyond planets, Webb maps vast galaxy clusters, showing gravity-weaving cosmic webs, where dark matter scaffolds structure, guiding visible matter into filaments, walls, and enormous voids across deep space, silently. Each unexpected observation forces scientists to rethink assumptions, refine simulations, and accept uncertainty, reminding us science advances not by comfort, but by confronting surprises revealed by better instruments continually evolving. Webb's legacy extends beyond data, inspiring technology, collaboration, and curiosity, proving that changing how we look can transform what we understand about the universe and ourselves profoundly today, tomorrow, forever. Looking deeper also means looking back in time, because every distant object appears younger, turning Webb into a time machine that reconstructs cosmic history frame by frame, without moving anywhere. This backward view reveals reionization, when early stars and galaxies transformed neutral hydrogen, allowing light to travel freely, ending the universe's dark ages and igniting cosmic transparency everywhere. Webb measures how fast galaxies formed stars, revealing intense early production, suggesting primordial environments were rich, energetic, and efficient at converting gas into blazing stellar populations surprisingly quickly. These findings challenge dark matter and feedback models, forcing scientists to reconsider how gravity, gas, and radiation interacted during the universe's first billion years of accelerated evolution. Webb also reveals supermassive black holes existing shockingly early, growing alongside galaxies, suggesting black hole formation and galactic evolution are deeply linked from cosmic infancy itself. Dust once thought rare appears abundant early, indicating rapid metal enrichment, meaning stars lived fast, died young, and recycled matter far quicker than traditional theories assumed possible. By mapping dust and gas, Webb helps decode why some galaxies stop forming stars, revealing how energy feedback heats material, halting collapse, and reshaping galactic life cycles. Closer to home, Webb studies solar system objects, from icy moons to asteroids, uncovering chemistry, surface activity, and origins that help explain how our planetary neighborhood evolved. Even familiar planets look new, as Webb detects atmospheric dynamics, storms, and heat patterns, proving advanced instruments can reveal unseen layers within worlds we thought we already understood. All these observations generate enormous data, demanding advanced computing, global collaboration, and patience, turning raw photons into understanding through careful analysis, debate, and scientific humility. Importantly, Webb does not replace older telescopes, but complements them, combining wavelengths to build a fuller picture, proving progress comes from cooperation, not competition, in science. With every update, Webb grows more precise, refining calibrations, improving sensitivity, and extending mission life, ensuring discoveries continue for years beyond original expectations. Yet Webb's greatest gift may be philosophical, reminding humanity that knowledge expands when curiosity outweighs fear, and when we dare to build tools answering questions older than civilization itself. By revealing how early galaxies assembled, Webb helps trace cosmic ancestry, showing today's spirals and ellipticals evolved from chaotic beginnings shaped by gravity, mergers, and relentless star formation over time. Webb's observations suggest mergers were common early, fueling rapid growth, triggering starbursts, and reshaping galaxies, proving collisions were creative forces, not merely destructive events, in cosmic history. As structures grew, gravity sculpted environments, influencing gas flow, star birth, and black hole feeding, linking small-scale physics with the universe's largest architectures in a continuous cosmic feedback loop. Webb captures how radiation from young stars heats surroundings, regulating further formation, showing star birth as self-limiting, balanced between creation and suppression across cosmic environments. These processes explain diversity among galaxies today, from quiet ellipticals to active spirals, revealing how early conditions determined long-term destinies written into cosmic structure itself. Webb's infrared sensitivity uncovers molecular clouds, detecting complex chemistry where simple atoms combine, forming the molecular groundwork necessary for planets, atmospheres, and potentially biological processes later. Understanding cosmic chemistry informs life's origins, linking interstellar molecules to planetary atmospheres, oceans, and organic compounds that eventually shape habitable worlds like Earth. Webb's data show early galaxies were compact yet massive, implying intense gravity and rapid star formation packed into small volumes, redefining how density influenced early cosmic evolution. Such density accelerates interactions, collisions, and feedback, explaining why early galaxies evolved quickly, burning fuel fast, and transforming their environments far sooner than later cosmic epochs. Webb also measures galaxy motion, mapping velocities through redshift, revealing how cosmic expansion and local gravity compete, shaping large-scale structure across billions of years. These measurements refine cosmological parameters, narrowing uncertainty about expansion history, matter distribution, and the universe's overall geometry, strengthening confidence while exposing subtle tensions needing explanation. Occasionally, Webb detects anomalies, objects brighter, heavier, or earlier than expected, forcing debates, rechecks, and cautious interpretation, reminding science advances through skepticism, not instant conclusions. Such debates are healthy, encouraging transparency, collaboration, and better models, ensuring discoveries mature from excitement into reliable knowledge guiding future exploration responsibly. Webb's long mission allows repeated observations, tracking change over time, revealing dynamic processes rather than static snapshots, transforming astronomy into a living, evolving narrative of motion. This temporal view uncovers variability in stars, planets, and disks, teaching that cosmic systems breathe, fluctuate, and adapt, rather than remaining fixed structures frozen in time. By linking scales from atoms to clusters, Webb reinforces a unifying idea. Simple physical laws operate everywhere, producing complexity through repetition, interaction, and immense spans of time. This unity connects humanity to the cosmos, showing we are not separate observers, but participants shaped by the same physics governing stars, galaxies, and the vast universe itself. Webb's discoveries also guide future missions, highlighting unanswered questions, refining targets, and informing designs for next-generation telescopes aiming to probe atmospheres, dark matter, and even earlier cosmic epochs ahead safely. International collaboration made Webb possible, pooling expertise, funding, and patience, proving humanity achieves more when nations cooperate on shared curiosity-driven goals beyond borders and politics, science, time, trust, risk together. Such cooperation builds scientific culture, training generations, sharing data openly, correcting errors, and sustaining long projects whose rewards unfold slowly, demanding commitment beyond individual careers and institutions worldwide, enduring purpose. Webb also demonstrates engineering courage, showing complex systems can deploy autonomously, operate remotely, and survive harsh environments when tested, redundant, and designed with humility, care, precision, discipline, foresight, planning, resilience. Failures avoided become lessons, improving standards, simulations, and reviews, ensuring future missions reduce risk, increase reliability, and push boundaries responsibly rather than recklessly through process, culture, learning, iteration, testing, rigor. As Webb continues, unexpected discoveries remain likely, because improved sensitivity reveals rare phenomena, transient events, and subtle patterns previously invisible within cosmic noise across wavelengths, epochs, scales, contexts, regions, everywhere. These surprises will refine theories, inspire debate, and recalibrate expectations, reminding scientists that nature owes no obligation to align with human assumptions or simplified models ever neatly, cleanly, fully, predictably. For students and dreamers, Webb offers perspective, proving curiosity can span lifetimes, careers, and continents, and that asking better questions often matters more than quick answers in science and life. It encourages patience, rigor, and wonder, values essential not only for astronomy, but for addressing complex challenges facing societies, technologies, and environments on Earth today, tomorrow, globally, ethically, thoughtfully, collectively. Ultimately, Webb reframes darkness as opportunity, teaching that hidden signals await those willing to adapt tools, rethink limits, and listen carefully to the universe with humility, patience, precision, curiosity, awe. Looking ahead, Webb helps prioritize which cosmic questions matter most, focusing research on origins, structure, and habitability, ensuring exploration remains guided by insight, not randomness or technological showmanship alone. By narrowing uncertainty, Webb transforms vague mysteries into testable hypotheses, shifting cosmic wonder from speculation toward disciplined inquiry grounded in observation, measurement, and repeatable evidence. This shift empowers science education, giving learners real discoveries to analyze, debate, and refine, replacing passive facts with active participation in humanity's ongoing quest for cosmic understanding. Webb also reminds us limits exist, as distance, faintness, and noise constrain knowledge, teaching humility and patience while motivating innovation to push observational frontiers further. Acknowledging limits prevents overclaiming, protecting credibility, and ensuring discoveries mature carefully, reinforcing trust between scientists, society, and the shared pursuit of truth over spectacle. As years pass, Webb's archive will outlive its mission, enabling future researchers to reanalyze data with new tools, extracting insights impossible to imagine today. This enduring value mirrors libraries of human thought, where knowledge compounds across generations, proving discovery is not a moment, but a process spanning time. Webb's success reinforces investment in science as long-term progress, yielding insights, technologies, and perspective that reshape civilization quietly, steadily, and profoundly beyond immediate returns. It shows exploration is not escape from Earth, but a mirror reflecting who we are, how we think, and what values guide our search for meaning. By listening to ancient light, Webb reconnects humanity with deep time, reminding us existence is brief, yet meaningful, when curiosity bridges past, present, and future. Webb's observations also highlight cosmic fragility, showing how environments change, stars exhaust fuel, and galaxies evolve, reminding us stability is temporary across scales, including civilizations relying on balanced conditions. This awareness adds urgency to studying habitability, as Webb helps identify environments where balance persists long enough for complexity, chemistry, and potentially life to emerge and endure. Habitability is not binary, but a spectrum shaped by atmospheres, radiation, chemistry, and time, expanding how scientists think about life beyond Earth's familiar template. Webb's measurements help eliminate false positives, teaching caution when interpreting biosignatures, ensuring claims of life rest on converging evidence, not isolated or misleading signals alone. This rigor protects science from hype, building trust and credibility, while preserving wonder, proving excitement and discipline can coexist without compromising truth or integrity. Beyond discoveries, Webb reshapes imagination, offering images that redefine beauty, scale, and perspective, influencing art, culture, and how societies visualize their place in existence. Such imagery bridges emotion and intellect, making complex science accessible, memorable, and inspiring, ensuring knowledge resonates beyond equations, reaching curiosity across generations and backgrounds. Webb reminds humanity that progress often requires patience, long planning, delayed gratification, and trust in unseen outcomes, virtues increasingly rare but essential for meaningful advancement. Its journey from concept to discovery shows perseverance through setbacks, budget debates, and delays can still yield transformative results when purpose remains clear and commitment endures. By succeeding, Webb validates ambitious science, encouraging societies to tackle hard problems rather than settle for incremental answers or short-term convenience. Webb also teaches restraint, reminding us not every mystery resolves quickly, and that uncertainty is not failure, but an invitation to deeper questioning. This mindset strengthens resilience, curiosity, and humility, qualities vital for scientific integrity and for navigating complex, unpredictable challenges beyond astronomy. Webb ultimately reframes humanity's scale, shrinking egos while expanding perspective, teaching that significance comes not from size, but from understanding and connection. By placing Earth within cosmic context, Webb underscores responsibility, suggesting knowledge should guide stewardship, cooperation, and foresight in caring for our fragile world. This cosmic perspective does not diminish humanity, but elevates it, showing awareness and curiosity themselves are rare, powerful features of the universe expressing itself consciously. Webb's continuing mission ensures future revelations, reminding us that knowledge is never complete, and that each answer opens deeper, more profound questions ahead. As discoveries accumulate, humanity's story expands, woven increasingly into cosmic history, dissolving boundaries between observer and universe through understanding. Webb's quiet orbit continues, listening patiently, proving exploration need not rush, because the universe reveals itself on its own timescale. In this silence, data accumulates, insights mature, and understanding deepens, reinforcing that progress often happens quietly, away from headlines and spectacle. Webb's story shows exploration is not conquest, but listening, patience, and respect, values increasingly relevant as humanity navigates its future within Earth's limits. By listening well, Webb transforms darkness into information, fear into curiosity, and distance into connection, redefining exploration as understanding rather than domination. This redefinition influences future explorers, scientists, and citizens, shaping attitudes toward knowledge, responsibility, and collaboration across disciplines and societies. Webb ultimately teaches that answers matter less than the capacity to ask, to observe carefully, and to revise beliefs when evidence demands change. This lesson extends beyond astronomy, offering guidance for decision-making, innovation, and cooperation in a complex, interconnected world facing uncertain futures. As Webb peers deeper, humanity learns to think longer, plan wider, and value knowledge that matures slowly, shaping wiser choices over time. In revealing ancient light, Webb does not answer everything, but opens space for reflection, humility, and renewed commitment to understanding our place in the vast unknown. The universe remains unfinished, and so does our understanding, but Webb proves progress lies in patience, precision, and courage to keep looking deeper. By changing how we see, Webb changes how we think, reminding us that perspective itself can unlock knowledge hidden within darkness. And in that shift lies Webb's greatest gift. Not images alone, but a quieter understanding that the universe reveals itself to those willing to listen carefully. Webb didn't just give us pictures, it changed our gaze, proving darkness can hold information if we learn how to listen. If that perspective shifted something inside you, join our curious tribe. Subscribe to Gurish Discovery, and if you felt the wonder, like, share, and leave your thoughts below. Because every answer is a doorway, not an ending. So here's the question we carry forward: what else is hiding in plain sight?